The spring of 1943 brought a peculiar spectacle to the testing grounds of Vickers-Armstrong in Newcastle, a sight that caused seasoned military observers to question whether a manufacturing catastrophe had taken place on the assembly line. British engineers, under immense pressure to deploy a weapon capable of defeating the terrifying German heavy armor appearing in North Africa and Europe, unveiled their latest creation. To the uninitiated eye, the vehicle appeared to be a chaotic mistake, a mechanical practical joke where the punchline was a 17-pounder, anti-tank gun mounted facing entirely the backward direction. The barrel of this massive weapon did not point forward over the hull, as military tradition and tactical logic dictated. Instead, it loomed over the engine deck, pointing directly at the rear. When the vehicle moved in what appeared to be a forward direction, the gun seemed to be retreating. When the vehicle was driving forward toward a destination, the gun was essentially useless, pointing back at the terrain they had just covered. Civilians who witnessed the prototypes rumbling down English country roads would stop and stare, genuinely confused by a tank that seemed to be permanently driving in reverse. Even within the military establishment, the initial reaction was one of bewilderment and deep skepticism. Officers at the first demonstrations suspected that the workforce, perhaps overwhelmed by the demands of wartime production, had simply assembled the turret wrong. Others wondered if the designers had ever actually seen a tank before. However, beneath this bizarre exterior lay a solution of profound pragmatic genius. Born of desperate necessity and the harsh realities of armored warfare, the vehicle, which would come to be known as the Archer, was not a mistake, but a calculated response to a crisis that threatened to derail Allied momentum in the war. To understand why such a strange machine was built, one must understand the environment of 1942 and the terrified reports. Coming back from British tank crews in Tunisia, the German Wehrmacht had introduced the Tiger I heavy tank, a machine that fundamentally altered the calculus of engagement. The standard British anti-tank weapon of the time, the Ordnance QF 6-pounder, was a capable gun against lighter armor, but against the frontal plate of a Tiger, which measured 100 millimeters of hardened steel, it was dangerously inadequate. At typical combat ranges of 500 to 1,000 meters, a 6-pounder shell would simply shatter or bounce off a Tiger's front hull. British crews found themselves in the unenviable position of having to flank these behemoths or close to suicidal ranges to have any hope of a kill, all while the Tiger's 88mm KWK-36 gun could destroy them from distances where the British tanks were little more than specks on the horizon. The psychological impact was devastating. Tiger panic was a genuine phenomenon, where the mere rumor of a Tiger presence could stall an advance. The British War Office knew they possessed the technological answer to the Tiger in the form of the Ordnance QF. This gun was a masterpiece of ballistic engineering, a 76.2mm weapon, capable of delivering a kinetic punch that could shatter the hull of any German vehicle in existence. When firing standard armor-piercing, capped ballistic cap-to-PCBC ammunition, it could penetrate roughly 130 millimeters of armor at 1,000 meters. When equipped with the new albeit scarce, armor-piercing discarding Sabat, a PDS rounds, the penetration figure skyrocketed to over 230 millimeters. This was enough to punch through a Tiger, a Panther, or even the King Tiger that would appear later in the war. The 17-pounder was the silver bullet the Allies needed. The problem was not the gun's lethality, but its sheer physical dimensions. It weighed over 2 tons on its carriage. The barrel was immense, stretching over 4 meters in length. The breech block was heavy, and the recoil forces generated when firing were violent enough to rock a heavy chassis and destroy a light one. Britain needed to get this gun into the field immediately, and it had to be mobile. A towed gun was too slow to set up and too vulnerable to artillery. It needed to be self-propelled. The search for a chassis to carry this monster weapon became a frantic exercise in elimination. The engineers at Vickers-Armstrong and the Department of Tank Design looked at every available option in the British inventory. The Churchill heavy tank was considered, but its turret ring was too small, and the suspension was not designed for the specific balance required by the set. The Crusader was far too light and mechanically fragile to handle the recoil. The new Cromwell tank was a promising candidate, but modifying it to take the large turret required for the gun would essentially require designing a new tank, a project that eventually became the Challenger, but would take far too long to be ready for the invasion of Europe. The clock was ticking, and the Tigers were waiting. The eyes of the designers eventually fell upon the Valentine. By 1942, the Valentine infantry tank was becoming obsolete as a frontline gun tank. Its slow speed and small turret meant it could no longer compete with the latest German Panzer. However, it was mechanically reliable, boasting a proven suspension and engine, and most importantly, it was available. Over 8,000 Valentines had been produced, and the Vickers production lines were fully tooled up to make them. If they could fit the 17-pounder onto a Valentine, they could have a tank destroyer in production within months rather than years. It was here that the laws of physics intervened. The Valentine was a small tank. The turret ring was tiny. There was physically no way to mount the massive 17-pounder in a rotating turret on the Valentine hull without making the vehicle dangerously unstable. If they mounted the gun facing forward in a fixed superstructure, the long, heavy barrel would protrude so far over the front of the tank that the center of gravity would shift drastically forward. The front suspension bogies would collapse under the weight, and the vehicle would constantly tip forward when braking or descending even a gentle slope. Furthermore, the recoil of the gun was so long that in a forward-facing configuration, the breech would slam back into the area occupied by the driver. It seemed an impossible puzzle. The gun was too big, and the tank was too small. This is where the ingenuity of engineer Leslie Little transformed a failure into a triumph of lateral thinking. Little realized that if the gun couldn't fit facing forward, he simply wouldn't face it forward. By mounting the 17-pounder firing over the rear engine deck, the entire dynamics of the vehicle changed. The weight of the gun was shifted back, balancing perfectly over the drive sprockets and the rear suspension. The barrel length was accommodated by the length of the engine deck, meaning the total vehicle length remained manageable. Crucially, the recoiled path of the gun breech was now moving toward the front of the vehicle, into the empty space of the fighting compartment, rather than into the driver's head. This layout allowed the driver to remain in his standard position at the front of the hull, separated from the gun crew by an armored bulkhead. The result was a compact, low-profile vehicle that used existing manufacturing jigs and tools. It was an ugly solution, a counterintuitive solution, but it was a solution that worked. The resulting vehicle, officially designated the self-propelled Valentine, MKI Archer, was a study in compromise and focused design. It carried a crew of 4 men, a commander, a gunner, a loader, and a driver. The fighting compartment was an open-topped armored box, offering protection against small arms fire and shrapnel but leaving the crew exposed to the elements. Snipers, and airburst artillery. The armor plating ranged from 14mm to 60mm, significantly thinner than a standard tank, as weight had to be saved to accommodate the heavy gun. This was not a vehicle designed to trade blows with the enemy. It was a glass cannon, designed to kill without being seen. Powered by a General Motors 660 426-cylinder diesel engine producing 192 horsepower, it could reach speeds of around 32 km per hour, while not fast by the standards of the Cromwell or the American Hellcat. It was reliable, and had excellent torque for maneuvering in muddy terrain. The interior was cramped, filled with the smell of diesel, cordite, and sweat. The crew sat surrounded by 39 rounds of massive 17-pounder ammunition, living and fighting in a steel box that felt more like a submarine than a tank. When the military establishment received the first prototypes for trials in mid-1943, the feedback was harsh. The Royal Artillery, who would be operating these vehicles rather than the Royal Armored Corps, was accustomed to towed guns or the American M10s, which had rotating turrets. The list of complaints was extensive. They despised the limited traverse. Because the gun was in a fixed mounting, it could only traverse 11 degrees to the left or right. To aim at a target outside this narrow arc, the driver had to rotate the entire vehicle. They complained about the lack of depression for firing from hold-down positions on slopes. They criticized the open top and the lack of space. To the artillery board, the Archer looked like a step backward. It lacked the flexibility of a turreted tank destroyer and the simplicity of a towed gun. Yet, despite these objections, the Ministry of Supply placed an order for 800 vehicles. The logic was cold and pragmatic. The Challenger tank destroyer was plagued with delays. The Firefly, a Sherman modified with a 17-pounder, was still in development, and the troops needed high-velocity guns now. The Archer was the only vehicle that could be produced immediately in the required numbers. The Archer entered operational service in October 1944, joining the war in its final, grinding phase. The sweeping maneuver warfare of the desert was over. The war in Northern Europe had become a slogging match through hedgerows, forests, and flooded lowlands. It was in this environment that the Archer's peculiar design ceased to be a liability and became its greatest tactical asset. The British Army quickly developed a specific doctrine for the Archer that turned its backward-facing gun into a lethal surprise. The tactic was known as shoot and scoot. In a conventional tank or tank destroyer like the American M10, if a crew fired from an ambush position and needed to retreat, they had to reverse out a slow process where the driver often couldn't see wheel or rotate the entire vehicle 180 degrees, exposing the thinner side armor and the high silhouette to enemy return fire. For the Archer, the retreat was instantaneous. The crew would reverse the vehicle into a firing position, tucking the low hull into a hedgerow or the ruins of a building. The Archer was exceptionally low, standing only 2.24 meters tall, significantly lower than a Sherman or an M10. This made it incredibly difficult to spot. The crew would wait, silent and hidden. When a German Panther or Tiger moved into the kill zone, the Archer would fire. The 17-pounder's report was deafening, the muzzle flash blinding, but the effect on the target was usually catastrophic. Then, before the German column could locate the source of the shot, the driver simply put the Archer into first gear and drove forward. There was no turning, no awkward reversing. The vehicle was already pointed toward the escape route. By the time the German turrets had traversed to where the muzzle flash had been, the Archer was gone, racing away to a secondary firing position to repeat the process. This unique capability confused the Germans, as much as it had initially confused the British observers. German Panzer commanders were trained to recognize enemy vehicles by their silhouette and behavior. They were looking for turreted tanks or anti-tank guns that had to be towed. They were not looking for a low-slung chassis that fired from the rear and vanished instantly. The Archer proved particularly effective in the dense, claustrophobic terrain of the Reichswald Forest, and during Operation Veritable, in early 1945, Imperial War Museum photographs from this period show Archers covered in mud. Operating in flooded streets in towns like Kranenburg and Gok, the flooded conditions actually favored the Archer. Its lighter weight compared to the heavier Churchills and Tigers meant it was less likely to bog down in the soft ground. In the hands of the 21st Army Group, specifically the anti-tank regiments of the infantry divisions, the Archer became a feared sniper of the battlefield. The Archer also saw significant service in Italy, arriving in 1945 to support the final spring offensive against the Gothic Line. Here, the terrain was radically different, mountainous, with narrow winding roads and steep gradients. Large, wide American tank destroyers often struggled to navigate the hairpin turns of the Italian mountain passes. The compact Valentine chassis, however, was perfectly suited for this environment. The Polish, the Second Corps, fighting alongside the British Eighth Army, utilized the Archer effectively in these difficult conditions. The ability to reverse into a tight spot on a mountain road, fire a round down the valley at a German roadblock, and then drive forward up the hill to safety made the Archer a favorite among crews fighting in the Apennines. The combat effectiveness of the Archer can be measured by what it could kill. The 17-pounder gun was, without hyperbole, the most dangerous Allied anti-tank weapon of the war. Against the Panther tank, which relied on its thick, sloped frontal armor, the Archer was one of the few Allied vehicles that could engage it with confidence, while the Panther's glacis plate, the sloped front armor, was incredibly tough and could sometimes deflect even 17-pounder rounds at long range. The turret front and the gun mantlet were vulnerable. More importantly, the Archer's accuracy allowed it to target the Panther's weaker side armor from ranges where the German tank couldn't effectively retaliate. Against the Tiger I, the Archer was deadly from the front at standard combat ranges. Crews learned to trust the gun. British artillerymen would paint the barrels of their Archers with a countershading pattern white on the underside and dark on top, to make the long barrel look like the shorter, less dangerous 75mm gun of a standard Sherman. This visual trickery often lured German commanders into a false sense of security, believing they were facing a vehicle capable only of scratching their paint, only to be hit by a high-velocity sabot round that tore through their armored dot. Comparing the Archer to its contemporaries reveals the stark differences in national engineering philosophies. The German equivalent, the Panzer IV, was also a turretless tank destroyer with a low profile. It carried a 75mm gun and had excellent frontal armor protection, allowing it to take hits. The Germans prioritized protection and a lower silhouette over raw gunpower in the early variants. The American M10 Wolverine, the most common Allied tank destroyer, took the opposite approach to the Archer. It was tall, heavy, and featured a fully rotating turret. This gave the M10 greater tactical flexibility in an offensive role. It could advance and sweep its gun like a tank. However, the M10's 3-inch gun was significantly weaker than the 17-pounder, and its high profile made it a magnet for enemy fire. In a static ambush, the Archer was superior to the M10 due to its lower height and better gun. In a mobile battle, the M10 had the edge. Interestingly, many British crews who had used the M10, named Achilles in British service when fitted with a 17-pounder, actually came to prefer the Archer for defensive operations. The reliability of the Valentine chassis was legendary, whereas the M10 required more maintenance and was harder to hide. The production of the Archer ended with the war. With 655 units completed out of the original 800 ordered, the cancellation of the remaining contracts following victory in Europe marked the end of its manufacturing life, but not its service life. The design proved so robust that it continued to serve long after the Nazis were defeated. In the post-war reshaping of the Middle East, the Archer found new owners. The Egyptian army purchased 200 surplus Archers from Britain following the 1948 Arab-Israeli War. These vehicles were maintained and operated. Into the 1950s, during the Suez Crisis of 1956, Egyptian Archers were deployed against Israeli, British, and French forces. It is a strange historical irony that British paratroopers and tankers, in 1956, found themselves being fired upon by the very weapons their own fathers might have built in Newcastle a decade earlier. Jordan's Arab Legion also operated 36 Archers, keeping the type in service well into the Cold War era. This longevity is a testament to the fundamental soundness of the engineering. A vehicle built as a stopgap emergency measure, utilizing an obsolete chassis and a controversial layout, managed to remain a viable weapon of war for over 13 years. The story of the Archer is a lesson in the value of asymmetric thinking. Faced with an engineering deadlock where conventional methods failed, The designers at Vickers Armstrong chose the path of greatest resistance to convention. They accepted that the vehicle would look wrong. They accepted that it would be criticized by the traditionalists. They prioritized the one metric that mattered most: the ability to deliver a 17-pounder shell to a target and survive to fire again. The backward-facing gun, initially seen as a flaw, forced the adoption of a tactical style that maximized the crew's survival chances. It forced the Archer to be used as an ambusher rather than a brawler. In doing so, it protected the thin armor of the vehicle by ensuring it was rarely seen until it was too late. Ultimately, the Archer stands as a monument to British wartime pragmatism. It was not a sleek, polished machine like the German Panther. It lacked the mass-produced uniformity and comfort of the American Sherman. It was a cobbled-together hybrid, a welding of a gun that was too big onto a tank that was too small. But in the hedgerows of Normandy, the forests of Germany, and the mountains of Italy, it earned the respect of the men who served in it. They realized that the odd appearance was irrelevant when the 17-pounder breached, ejected a smoking casing, and a distant enemy tank erupted in flames. The Archer proved that in war, if it looks stupid but it works, it isn't stupid. It was a machine that turned its back on the enemy to fight them. A mechanical contradiction that became one of the most effective tank destroyers of the Second World War. The confusion of the civilians on the English roads and the skepticism of the officers at the trials were eventually replaced by the quiet appreciation of crews who knew that this backward-driving oddity was the only thing standing between them and the heavy armor of the Wehrmacht, and that, in the end, was all that mattered.